Hello everyone and welcome back. So after the main wedges, let's see whitewater solver foam type wedges. So we are going to talk about now the main attribute for getting that foam look. Okay, so let's see our reference video. So the first one is going to be constraint stiffness, and I run few wedges just to see how strong I want to have my foam for more clumpy look. So if you see the reference, so it's more or less like in these areas here, or maybe even in this area here, how strong we want to form these small clumps of foam. So this was the first wedge for the foam type of our whitewater solver. After that, the next one was erosion. Just want to see how fast we want our foam to die or stay in a denser area. So as you can see here, different look, die faster or stay longer. Only the high dense area it's going to stay longer. Also, this is something that you could try on your simulation to see if this is going to add more realistic look. After that, we are going to try to get that foam look with repel strength. So these are the few wedges that I also try from this lighter values like 1 and 4 to the really strong values like 10 and 20. As you can see, this is more like diffuse type of foam, and this is more like really fast getting that cellular type of look for our foam. So we can also try and match your reference to see which one is of this value are close to your shot. After that, the next one is actually size of our repellents. So this is from 0.1 and 0.2 going to the really high values like 0.05 and 1. So you can see the difference in a cellular size. And for example, this is really too much, but it's really good to run some higher values so that you can actually see the difference in our size. So if we look and compare to our reference, these smaller values are something that is close to this the first one with 0.1 and 0.2 is close to our reference. After that, the next one is trying the match radius distribution. So it's coming here, just trying to add random also size with a ramp between our minimum and maximum range size. So if we go back and see, so these are some ramps that I tried. So let's put the cache to load faster. Some of the ramps, so this is just default one, and these are different look of my ramp. So more of the smaller value and really less of the higher value. Here is it's just coming from the smaller value to some mid-range, and no more higher, larger size. On this ramp is just really small and at the end large, and nothing in between. And then I also try different variations with the different look of the ramp, just to see what is going to happen. Here we only have like smaller values, and here it's only higher values for our repellent size. So just trying to see which one is going to look more interesting. So for example, this one with only smaller values, it's more or less in terms of scale proper to to our surfboard. So if we come here and see how this real, for example, if this is the chair, so we can see the size of our foam pattern, and so with this kind of wedges we can easily try every variation and see which one is going to be good for us. Then there is also one, and this is the last wedge for match radius distribution. Again, also trying different style of the ramp and see, at the end you're not going to use maybe not even any of these three type of wedges with different ramps. Maybe at the end you are going to find like final version, but it's really good that you try different variations and see how they work. And this is also the learning process. So as in some other tests, you already know how this ramp is going to work, and how you can tweak that your foam look different in certain areas. After that, the next step is trying to break our circle look of our foam with with the noise range. So this is for different wedges coming from the default one 0.1, then we are going to 0.3 to 1, and the final one is 0.9 to 1. As you can see, noise, there is no anymore this circle look like on the first wedge. And this is also to break your uniform look of your foam. And then there is a pulse frequency, also something that we already talk on on the whitewater jump, how fast you want this frequency noise to act on your whitewater seam or repellents. And this is also one way to break that uniform look, to add even more randomness. And this is more or less all the wedges that I run, and most important one that I run for for the whitewater foam tab. And after all these wedges, I can see what kind of values I'm going to use. So the last wedge in this first initial set was whitewater scale versus emission amount, because sometimes when you use higher or let's say smaller values for whitewater scale to have more detailed simulation, emission amount sometimes is going to add, if you use like 1, you are going to have a lot more particles. So maybe this is something that you don't want. And if you remember in a previous video where I only test emission amount, so in this case I was trying to test whitewater scale and emission amount to compare and to see what kind of values are not going to give me. They are going to give me a lot of details but not a lot of particles in my simulation. So in this case whitewater scale was 0.0125, but actually emission amount was 0.1. If I use like emission amount of 1, this would be more or less covered with points everywhere, and this is something that I didn't want. So I wanted to have to see actually my fluid, and also have nice whitewater details. So if we compare, this is something that we can see here on the areas here where we can actually see our main fluid, but also whitewater, but still we have really nice details and details on the beach itself, and nice repellents and foam, and everything is there, but just the amount of points is perfect for this whitewater scale. So that's it for now. So let me show you. So my final settings, okay, so my final settings for the whitewater seam, as you can see here. So match distribution radius, what kind of ramp, density threshold, what frequency range, noise range, strength range for my repellents, then the size also, and constraint stiffness, and neighborhoods and maximum neighborhood size. Also the velocity multiplier, lifespan, aging rate for bubbles and foam, whitewater scale, voxel size, depth range. So this is, after all my testing, I found this, setting to be perfect, for my beach simulation. So the last and the final result is actually look like this. There is enough details and also not so much, white water in the deeper area, so I can see my fluid. But there is one problem that we need to address, is that, as you can see here, the lead edge and also the white water on our beach is actually too strong to form, like this cellular type of look. And also we don't have that nice front lead edge that we have, like here. And for example, in this area here, you can see that white water, it's actually more diffuse look than actually, like in this area deeper into the water, where we can see actually, the foam shape. So as you can see, with our initial fluid simulation, we have a lot of problems on areas. Okay, let's wait till it cache load. So let's put so in the areas on the beach itself, and if we compare, with our reference, we need to get, some type of, this look like nice smooth, front lead edge, and also the water that is coming back into the ocean, or let's say foam that is going back into the ocean, that need to have this kind of, diffuse look without, too strong, foam shapes or cellular type shapes. So this is something that we are going to address in the next few videos, and I will try to explain you, how we can deal with these kind of problems, and how to solve them. Maybe not that easy, on some cases, but I will try to, show you some ideas how you can put that in your shot. Okay, so let's continue in the next videos. Bye.